Section 13.3, the pH scale. Super duper important, but also pretty darn easy. The pH scale is a compact way to represent the solution's acidity. The pH is a log-based scale on base 10, where our pH, I'm going to give us a little lowercase p out in the front, and that lowercase p is going to be minus the base 10 log, and then of the H plus. There are lots of other P functions out there. So we're going to see POH, which is going to be minus the base 10 log of the hydroxide ion concentration. You could see PCA plus if you're doing neuron transmission and you're looking at how much calcium concentration is being released by a neuron. You could see pKa, like if you're looking at an amino acid. Oftentimes they'll list a pKa, which is minus the base 10 log of the Ka of that amino acid. It's going to change by 1 for every power of 10 changes in H+. So that if your pH goes from 1 to 3, it's a 100-fold change. Right? The pH decreases as H+ concentration increases. So lower is more acidic. For a solution where H+ is 1 times 10 to the minus 7 molar, our pH is going to be equal to minus the base 10 log of 1 times 10 to the minus 7, or minus 7, which is going to be 7. So our pH is going to be 7. That's our neutral point. So the pH for pure water, which is pH neutral, is going to be 7. So 7 is kind of our resting point for water at about 20 degrees C. The pH scale was developed by Danish biochemist Soren P.L. Sorensen while working on the brewing of beer. The letters in pH are an abbreviation for pondus hydrogenii, which translates as the potential of hydrogen. So when we're looking at our sig figs for doing our logarithms, the number of decimal places in the log is equal to the number of significant figures in the original number. So if we've got H+ concentration as 1.0 times 10 to the minus 9, we're going to keep 2 decimal places over here. We'll call that pH 9.00. And notice this little bit here, right? This 9 roughly matching up with this exponent over here. So you can get a rough idea of where a pH is just based on looking at the exponent on the concentration. Log scales are used for representing other quantities, POH minus log of the OH minus ion concentration, pKa. And why are we doing this P nonsense? Because it is much easier to write out pH 9 than it is to write out the concentration of H+ as 1 times 10 to the minus 9 molar. Right? It just saves us some time, and it gives us some more easy and amenable number for us to work with in our limited human brains. Yep. So let's look at our pH scale. Our pH of 7 is going to be neutral. And so pure water is going to be neutral. Something that is basic or alkali, like lithium, right, is going to have a pH that is above 7. So you're basic up above 7. And acidic, you're going to be less than 7. The lower the pH, the more acidic it is in solution. And if you look at some of the common things that we've got, something like coffee is slightly acidic, and it's going to be a pH of 5. Right? Vinegar and lemon juice are coming in around pH of 3. Stomach acid's about a pH of 2, right? That's HCl. 1 molar HCl is going to have a pH of 0. Right? So our H+ scale, right? Notice these guys all have exponents that are going to correspond to the pH. Right? So we have 10 to the minus 14, it's going to be a pH of 14. And 10 to the 8th is going to be a pH of 8. So seawater and blood are a little bit basic. Baking soda is a little bit basic. Ammonia, household ammonia, is going to be about a pH of 12. And pure sodium hydroxide, 1 molar sodium hydroxide, will be a pH of 14. Let's do an example. I'm going to calculate the pH and POH for each of the following solutions at 25 degrees C. Again, we're specifying the temperature because our pH scale will change with temperature, but it's almost always going to be pH at 25 degrees C. So if we have 1 times 10 to the minus 3 molar hydroxide and B, 1 molar hydroxide. So for a 1 molar hydroxide, we're going to do H+ is Kw over OH minus. So it's going to be 1 times 10 to the minus 14 divided by our hydroxide ion concentration, 1 times 10 to the minus 3, means that we've got 1 times 10 to the minus 11 molar H+. So our pH is going to be the minus the log of the H+ concentration. We're just going to plug this guy in here. and we'll do minus log of 1 times 10 to the minus 11, or 11. And we're going to do the same thing when we calculate our POH, except we're just going to look at the log of the OH minus ion concentration, which we said was 1 times 10 to the 3. So our POH is going to be 13. And here's a nice nifty little relationship, is that pH plus POH is going to be equal to 14. Right? There's that number 14 showing up again. Or you could do something like this, which is more practical. 14 minus pH is equal to POH, and vice versa. Right, so sometimes you've got one of those, and you want to find the other one, and you don't want to do all of this math with the logs. You can just do 14 minus POH is the pH. Here's our solution B. We could do OH minus concentration divided by Kw. So we do 1 times 10 to the minus 14 divided by 1, which was our H plus concentration. 1 times 10 to the minus 14 molar. We're going to take this, plug it into our P function, which is minus base 10 log. And we'll do minus base 10 log of 1, or 0. So our POH is going to be minus the base 10 log of the hydroxide ion concentration, which is 1 times 10 to the minus 14, or 14. All right, so we could also say Kw is equal to H plus times OH, or the log of Kw is going to be equal to the log of H plus the log of OH minus, or we could say minus log of Kw is minus log of H plus minus log of OH minus. So pKw is equal to pH minus POH, and our Kw is 1 times 10 to the minus 14, so pKw is 14. So minus log of 1 times 10 to the minus 14 is 14. Any aqueous solution, pH plus POH is equal to 14. Right. What's neat is that if you have one of these values, H plus, OH minus, pH, or POH, you have all 4 of them through some sort of simple conversion. Right? If you've got an H plus concentration, you can do minus base 10 log to get pH. Well, if you got a pH, you can do 10 to the minus pH and get H plus. If you've got a pH, you do 14 minus pH to give you POH. If you got a POH, you can go backwards and find pH doing 14 minus POH. If you got a POH, you do 10 to the minus POH to get your hydroxide ion concentration. If you've got your OH minus ion concentration, you do 10 to the minus base 10 log of the OH minus ion concentration to get the POH. So if you've got any one of these, you can calculate your way to the other 4. And you can actually get through this way by using your Kw expression as well. So it's actually a little shortcut in there too. Okay. So let's look at an example of calculations using pH. The pH of a sample of human blood was measured to be 7.41 at 25 degrees C. We're going to calculate the POH, H plus ion concentration, and hydroxide ion concentration for the sample. Easiest one to go for is the POH. So since pH and POH together are equal to 14, our POH is just going to be 14 minus the pH. So we'll do 14 minus 7.41, gives us 6.59. To find H plus, we're going to go backwards. So since pH is minus the base 10 log of H plus, right, we want to go the other way. Right, we know that minus the base 10 log of our H plus ion concentration is 7.41, or the log of H plus is minus 7.41. We're just going to do the antilog, or 10 to that. So we're going to do 10 to the minus pH. Right, so we're going to take the antilog of the pH. So H plus concentration is the antilog of pH. So H plus is the antilog of minus pH, which is the antilog of minus 7.41, or 10 to the minus 7.41, 3.9 times 10 to the minus 8. If I wanted to, I could use that relationship between Kw and H plus and OH minus, knowing that this number times X is going to be 1 times 10 to the 14. But I've already got OH minus ion concentration tied up in the POH, which we did earlier. So we're going to do our hydroxide ion concentration is going to be 10 to the minus POH. POH. And that's going to give us 2.6 times 10 to the minus 7. And if you want to double check, those two together are going to equal 1 times 10 to the minus 14, right? And you can kind of look up here. I got a 7 and I got an 8. And if I factor in that they're not all just unity, I'm going to end up with 1 times 10 to the minus 14.